we announced this thing called Dynamo,
Right.
disaggregated AI workload orchestration, and we open sourced it because the future AI factory is disaggregated.
Right.
And you launched MV Fusion
Yeah,
that even said to your competitors,
yeah,
including Intel, which you just invested in,
that's right.
you know, the way in which you participate in this factory that we're building, because nobody else is crazy enough to try to build the entire factory, but you can plug into that if you have a product that's good enough, compelling enough that the end user says, hey, we want to use this instead of an ARM GPU, or we want to use this instead of your inference accelerator, et cetera. Is that correct?
We're delighted to connect you in. Yeah.
Tell us a little bit more.
NVLink Fusion, such a great idea. And we're so happy to partner with Intel on that. It takes the Intel ecosystem. You know, most of the world's enterprise still runs on Intel. It takes the Intel ecosystem, takes the NVIDIA AI ecosystem, accelerated computing, and we fused it together.
Right.
And we did that with ARM, right? And there's several others we're going to be doing it with. And that opens up opportunities for both of us. It's a win for both of us. Great win. I'll be a large customer of theirs, and they're going to expose us to a much, much larger market opportunity.
Yeah.
This deeply related to this idea is the argument you've made that kind of shocks some people, where you say our competitors building ASICs, they could literally, all their chips are cheaper already today, but they could literally price them at zero. Our objective is they could price them at zero, and you would still buy an NVIDIA system because the total cost of operating that system, power, data center, land, et cetera, the intelligence out is still a better bet than buying a chip, even if it's given to you for free.
Because the land, power, and shell is already $15 billion.
Right. Yeah. So we've taken a crack at kind of the math on that, but walk us through your math, because I think for people who don't spend as much time here, it just doesn't compute. How could it possibly be that you were pricing your competitors' chips at zero, given the expense of your chips, and it still is a better bet?
There's two ways to think about it. One way is, let's just think about it from a perspective of revenues.
Yes.
Okay. So everybody's power limited. And let's say you were able to secure 2 more gigawatts of power. Well, that 2 gigawatts of power you would like to have translate to revenues.
Yes.
So your performance or tokens per watt was twice as high as somebody else's token per watt, because I did deep and extreme co-design.
Right.
And my performance was much higher per unit energy, then my customer can produce twice as much revenues from their data center. And who doesn't want twice as much revenues? And if somebody gave them a 15% discount, you know, the difference between our gross margins was, call it 75 points, and somebody else's gross margins, call it 50 to 65 points. It's not so much as to make up for the 30 times difference between Blackwell and Hopper. Let's pretend Hopper's an amazing chip, an amazing system. Let's pretend somebody else's ASIC is Hopper.
Yeah.
Blackwell's 30 times. So you've got to give up 30x revenues in that 1 gigawatt. It's too much to give up. So even if they gave it to you for free, you only have 2 gigawatts to work with.
Right.
Your opportunity cost is so insanely high. You would always choose the best perf per watt.
So I heard this from one of the CFOs at one of the hyperscalers, that given the performance improvement, right, that's coming out of your chips, again, precisely to that point, tokens per gig, and power being the limiting factor, right, that they had to upgrade to the new cycle. So when you look ahead at Rubin Ultra, at Feynman, does that trajectory continue?
We're building, 6, 7 chips a year now?
Yeah.
And each
As
one
part of that system.
That's right. And that system, software is everywhere, and it takes the integration and the optimization across all of those 6, 7 chips to deliver on the 30x Blackwell. Right. Now imagine I'm doing this every single year. Bam, 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 bam. And so if you build one ASIC in that soup of ASICs, in that soup of chips, and we're optimizing across that, you know, it's a hard problem to solve.